which
Sure.
people probably don't even know this. I mean, I can fit 5 times as many cores into the same real estate on a chip than I could 10 years ago,
Right.
which is astronomical. It's incredible. And
Yeah.
the number of
You
cores
know,
I can have on a single computer are in the hundreds now.
yeah, I look at that old Cray machine, the first one I ever ran on. I think it was called Beagle, actually, and I don't even remember the exact specs on it. But that exact system, I kind of want to do this after, compare what it would look like today on even some of the newer, let's say, cloud instances coming out.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsipher, Chief Solution Architect, author, and most importantly, your host. On today's episode, The Perfect Storm, Cloud, HPC, and AI, with special guest Matthew Shaxted, President of Parallelworks. Matthew, welcome to the show.
Thanks, Darren. Happy to be here.
Hey, we had a great conversation at FCA West. When was that? 2-3 weeks ago?
2 weeks ago? I don't know. Time moves fast.
Something like that. And it just brought me back. You knew some of the people I used to do work with in the Global Grid Forum and the Open Grid Forum back at the turn of the millennium. I had a lot of fun doing that stuff. And you brought me back to those times. So I said, we have to have Matthew on the show because you actually have something to say besides just reminiscing with Darren. But before we get into that, Matthew, tell my audience a little bit about yourself, your background, and why we're talking to you today.
Sure. Yeah. So I'm Matthew Shaxted, President of Parallelworks. Sure, we'll get into what we do a little bit more. But I have a background in civil engineering, actually. And I was a practicing engineer at some large architecture and engineering firms in Chicago. That's where I'm born and raised, running a whole bunch of different types of simulations for that industry. So structural, CFD, we did a lot of topology optimization, radiance analysis, energy modeling, a wide gamut of simulation physics. And when I was in these companies, my job was to take the designs and try to make them better through simulation. So long story short, I needed bigger computing resources to run these type of things. That led me to Argonne National Lab, which is the Chicago area, one of the leadership computing facilities in the country. And the process began how to start running on the big iron machines, right? I met my partner and co-founder of the company, Mike Wild. He's our CEO there. That was in 2014, I think. So almost 10 years ago now. And they developed technology at Argonne and through this research team, somewhat affiliated to the Globus Group and Grid FTP and all that.
I know the Globus Group well. Yeah,
there you go. Yeah.
Awesome.
But it created technology that helps you scale workflows from your desktop or maybe a small set computing environment up to these massive machines. And I remember very clearly the first simulation I ran on, I think it was some older Cray model sitting on Argonne's floor. And it was like 20,000 cores. And, before that I was used to 100 cores here, maybe my laptop simulation. So the first time being able to run 20,000 cores all in once, in a matter of, doing more work, computing work than I probably ever achieved. I was like, wow, this is amazing technology. So we basically spun this workflow fabric. It was called Swift at the time. It's evolved since then. Spun that out of Argonne. It was Apache 2 license, so it was pretty easy to do that. And we created what is now Parallelworks. And it started very much focused on basically commercializing this workflow fabric, making it easy for industry to scale it and democratize their primarily HPC related workloads. But over the 10-year timeframe, it's kind of evolved much more into, hybrid multi-cloud computing environments. So we do a lot of HPC, but more and more they're turning into ML and like the intersection of ML workloads with HPC. So I'm sure we'll talk more about that, but yeah,
that's really interesting because I dabbled in that world 20 years ago. where I know the Globus guys really well because I did a lot of work with them. But what I thought was interesting at the time was the only people really using high performance computing, these massive machines, were scientists or anyone that was running big, huge simulations, right?
Yep.
Whether it's nuclear explosions or weather prediction or crunching numbers coming off of the CERN super collider, whatever.
Mm-hmm.
But I mean, these machines cost hundreds of millions of dollars, right? So they weren't just handing them out to any, consulting firm or a civil engineering firm that was doing whatever. But I think it's interesting because we're back 20 years and now we're back to maybe more people can start taking advantage of these HPC clusters, which now are kind of scattered all over the place.
And the shape of them has kind of evolved too, right? I mean, conventionally HPC is, and I kind of always think of it as lots of computers working together to solve one big problem, which is where, why these systems are so expensive and very specialized. And, now cloud comes along, and for a long time, the performance to achieve those same type of workloads, lots of cloud instances working together to solve one problem for many years kind of wasn't there, or, people didn't think the performance was there. And then the total cost of ownership is higher. And for, we've been doing this for 10 years, right? So I've kind of watched, we were trying to go hybrid cloud before it even was a thing. And before people were even convinced it could perform as well as like a few generation old Cray machines. And now over the last, maybe 3 or 4 years at least, I've been seeing those things kind of converge, where you can actually show that these cloud resources can be configured in such a way that can compete with, not the latest and greatest, conventional supercomputing machines, but, several generations old, and then the cost of ownership becomes somewhat comparable. So there's like this convergence point where now cloud can offload a lot of what people do on conventional HPC systems. And it's enabling a whole bunch of new things, which is where I think ML kind of plays in.
Yeah, before we talk about ML, I think I want to touch on this a little bit. The HPC clusters, 10 years, you've seen the density go 5x, which people probably don't even know this. I can fit 5 times as many cores into the same real estate on a chip than I could 10 years ago.
Right.
Which is astronomical. It's incredible.
Yeah.
And the number of cores I can have on a single computer are in the hundreds now.
Yeah, I look at that old Cray machine, the first one I ever ran on. I think it was called Beagle, actually, and I don't even remember the exact specs on it. But that exact system, I kind of want to do this after, compare what it would look like today on, even some of the newer, let's say, cloud instances coming out. You can just fit a lot. They're much higher, capability than even these machines. So yeah, there's been a lot of movement there.
So what that means is the workloads that used to cost me, where I'd have to buy a supercomputer to run with, tens of thousands of cores, I can now run and spin up in a cloud and run it in a shorter period of time. It only cost me $1,000 instead of millions of dollars. Potentially.
I think, it depends on like any response here, depends on the shape of the workload. There's ones that, and we handle kind of both cases. We have workloads that want to run 1 million tasks on some group of instances, and they're totally unrelated. And cloud instances in particular are really good at those. And you can spin up a lot of nodes and you run them in containers and they're all processing and you can have fault tolerance on it. And those things, yes, each individual task may process faster. And, each CSP, cloud service provider, is generating, they're bringing on the next set of Intel machines and AMD and NVIDIA, and it's a race, right? It's always happening.
Well, we don't like to talk about those other guys. But
yeah, okay, I'll keep it focused, right? Yeah. So the newest, and we were just talking about the AMX accelerators from Intel, right?
Oh
They're
yeah,
in the 7 series on AWS. So like those things get introduced, we go and run the same workloads we were running on the 6 series over there, and it's suddenly you get a 10% boost in performance for like same cost or a little less. And so that's happening a lot. But
so
yeah.
Because of that, because compute is becoming even cheaper to consume, either in the cloud or on-prem, they're both becoming very easy. That means there's more workloads I can actually run, and the purpose-built machine doesn't really have as much of a play as anymore because they're running so fast. I can run multiple different types of workloads on the same clusters. Is that?
I would say I think that still is it depends problem, because there's still the class of workloads that need to go even with faster and faster hardware, and maybe one point we'll reach a convergence point, right? And this will completely, I can do everything I'm trying to do. Like, with our NOAA engagement, we have an acceptance test that runs on, we have to compare it to their about 2 to 3 year old Cray machine. It's a 5,000 core job. We run it on the C5 series instances on AWS, right? It still takes, it's 5,000 core job on AWS on those series. And it's about 100 nodes working together, right? Maybe one day all those things will converge and I can do that on my phone. Yeah. But for now, even, the HPC 20i series, whatever, it's, maybe at that point it start to converge. But what's happening is you change the shape of the actual jobs themselves. So instead of 100 nodes, of a certain type, now we can run it on 50, get a performance boost, and you spend, half the cost. And that's exactly what we're seeing on, this hardware kind of race that's going on, I'll call it. Every quarter new series are coming out. We go and run our same benchmarks and show, hey, here's your 20% boost at less costs. And
right. No, that makes sense. Now, even with the hardware becoming more accessible, it's still, I remember setting up these clusters. It's still hard to set these clusters up and to tool my job. My workload, I have to tool that up to take advantage of massively parallel. It's still a lot of work.
Still a lot of work.
but you guys, that's where your sweet spot is, right? That's where you're trying to make
that's
it
kind
easy.
Of the whole reason we exist, really, because if it was really easy to leverage, lots of these computers all working together, right, and configure them and tune them, we would have levels of value in the space, right? The reality is right now, when you want to actually leverage these things, there's a lot of intricacies that start to come into play to get top performance out of it or get best cost performance, which is a big component. And you don't really start seeing these things until you get in under the covers of it. But it's like, all the networking configurations, when you go multi-cloud, every cloud service provider has a different recipe for extracting best performance out of their network, for example. And if you don't do these things, it won't perform because this one is still, using TCP over, Ethernet. This one's using some Mellanox driver that's been configured. This one has their specialized interconnect that bypasses. So each one is like very different. And, in a world where you can just pick one and work in that one for a long time and get a lot of experience there, it's great. And you can be very successful doing that. I think we've been seeing more and more organizations wanting the ability to go between these different environments. And in a way, treating their on-prem environments in the same type of category. And they just can select which one when. Yep.
Why would I want to do that? Why do I want to run my HPC workload sometimes on Google, other times on AWS, other times on Azure, or other times on-prem? Why have that flexibility? Why not be the master of my own cluster? Because I can control everything in my own cluster. I don't have noisy neighbor problems. I don't have security problems. Everything's contained. So why go beyond those walls?
Yeah, I mean, I think it's a few categories there. It's economics, right? So still, if you have the capability to do so, managing your own sets of resources is still, I think what generally is perceived as the lowest total cost of ownership when you have those capabilities, in-house already. What happens though is you're generally under a lot of resource contention, and when you have engineers or people training ML models, or in the case of like defense work, doing some mission critical scenario playing, people can't wait a week for their job to start. There's a resource contention problem, right? So that's where just having the ability to now burst out into these other environments is very valuable. And people say a lot, buy the base, rent the rest. That's like kind of a phrase.
I like that.
Yeah, I've been hearing that. That's a phrase said, and we, you get the capability to do that. Also, though, we've been seeing the on-prem refresh cycle of these systems. It's kind of on the order of years, right? I mean, you can't go get in the newest FPGAs from that AWS is going to be rolling out like next quarter into your own shop as quickly, generally speaking, or the new accelerator version from Intel, right? Having the ability to now say, we're going to go and run on these AMX accelerators tomorrow and not have to wait. That's a big consideration as well.
Okay, so that makes sense to me, right? I can get access to new technology immediately, or as soon as it's available in the cloud. Where if I were to buy it myself, that's expensive. There's one thing you said that I thought was interesting: resource constraint. Are these supercomputers constantly running all the time?
No, I think generally, for what I've seen, these centers, they try, these facilities or organizations that have these internal resources, they keep them as heavily utilized as possible, right? Because it's a one, big CapEx outlay. And then you're trying to maximize the usage of it before it gets too old, really, which is, 4-year time. And now you got the next refresh, right? So
I hope it's every 3 years, right? I want it to be every 3 years that they refresh.
Right. Exactly. Yeah. Right. So generally they are very constrained. I won't say specific orgs, but we have ones where it is literally you submit a job into the cluster and you wait a week before it stops or before it starts. And
before it starts. Well, wow.
Before it starts,
wow.
You make a mistake and then it's like, oh, I got to go wait another week. And yeah, you can get priorities, but they're very heavily constrained.
There's other jobs running there. All right. Yep. So you guys provide an easy way then to span on-prem, in the cloud, multi-cloud. So is that's your focus of your company, is to make that easier for me as a scientist or whatever, to run HPC workloads anywhere. So I can take my scripts, whatever I have, I just hand them to you, and
that sounds really easy. So in theory, yes. In theory. But for us, it even starts at like the organization level. So like an organization and the people that are managing the computing systems within an organization that are even starting to look at cloud, which is everybody's having these discussions now, and many, everyone's in different places on it. We kind of start in that level because we go in and present ourselves as really just like we are a portal for your on-prem systems. We make it easier for your user base to consume your on-prem resources that you have. It's basically, look, the terminal is the old way of accessing these things. We give you a place where your users can get Jupyter notebooks or VDI sessions or do more advanced, data flow, but on your existing resources, right? People have called these things portals for years, and we're an on-prem portal. Some other thing, in this camp, it's like GreenLake by HPE. It's Open On Demand is a big one. That's like the open source version focused on the on-prem side of things. A lot of companies roll their own too. They just
Yeah. We did when I set up clusters at Cadence Design Systems.
Cadence Design Systems, yes, exactly right.
Yeah, 5,000 nodes of old machines. We did crazy things. We grabbed all the old machines that people didn't want anymore, threw them all into one big, massive cluster, 5,000 machines, and we set up our cluster that way. And we use that. We use every compute cycle we could possibly use every night. Yeah, it
Yeah,
was
I mean,
cool.
so the concept of a portal is not new.
That's
And
not new.
so,
Yeah.
and even, we do defense work, right? And the HPCMP, the mod program that manages a lot of the unclassified and classified, high performance computing systems, they've been creating portals for those systems for about, a decade or more, like 15, even more. And they're great. You can log into them. You have the ability to get into a terminal very easily. You have the ability to submit simple jobs. So we're kind of like a enhanced supported version of that at the base. But now we layer in this cloud bursting and this kind of, multi-cloud component where, yeah, go ahead.
So this is really interesting to me from the perspective of, if I can burst into the cloud, am I taking my individual job that I'm running? It may have several hundred, jobs underneath it. It may have
Mm-hmm.
5,000 cores. When you say burst into the cloud, am I then running my job across the cloud boundaries, or am I moving my whole job up into the cloud? So there's no contention at all on the on-prem,
Very,
or can I handle both?
that's very workflow specific, I'd say,
Oh, okay. Oh,
and
cool.
organization specific, and then it quickly becomes a data gravity issue.
Oh, yeah. Your data is your biggest problem, right?
Yeah, because if you start, and we have had customers, right, that do have a workflow that wants to run in our environment, and they want to run some jobs on like their on-prem GPU cluster, for example, or GPU resources, and then they want to take certain tasks of the workflow and run it on like a big AWS, set of resources. And so that truly is like a hybrid workflow, and you're moving tasks between it. And inside of the actual workflow executions, there's the data process, right? You're moving data either explicitly or you're transparently moving it through some type of data mover. And so that does exist. I think more typically we see things where it's like, I'm going to try to run on the on-prem resources when I can, and when I, as available. When I need to, I can just take my workload and point it explicitly to an
AWS,
to a cloud service provider cluster. Yeah. So it is a little bit more like choose one of the sites you want to run on, and get the data there. Yeah, get the data there and then run it over there.
Now, another thing that you mentioned to me is, and a big concern, because we had a customer that wanted to run HPC in the cloud. I'm not going to mention who they are. They know who they are. I don't want to embarrass them too badly. But they set up a couple nodes in the cloud in their cluster and a couple nodes on-prem in the same cluster. And they were just running their jobs. And their egress costs went through the roof. And they ran through their whole budget in like a year's budget in a month on their cloud.
So this is where it is very, it's a workload specific kind of conversation, because, and we have similar things, we have groups right now that are spending $50,000 a week on egress costs or something, going out of AWS back to their on-prem data transfer nodes. Right. And
to me, that's just wasted.
They're fine with it. And there's also some things happening in the cloud service provider world now where, some of these cloud services, they're getting rid of egress costs. It's a competition.
Oh, yay.
Right? You can start. And so now, we have the ability, to go to a site, a cloud service provider, you don't have egress costs, right? You don't have to change everything you're doing through our system, but that's separate. So regardless, though, it still becomes the same conversation. What needs to, do you really need to move back the 50 terabytes of data that were generated from your, whatever weather forecast job or something? What can stay in the cloud? Can you post-process in the cloud to make it smaller? It's kind of part of that whole discussion.
So it's not as easy as I'm just going to take my workload and just jam it into the cloud. I have to think about it still. There's some things I have to think about: data movement. What value am I getting out of that? Now, you guys have some tools to help me with my cost controls, correct?
Yeah. So, and honestly, just touching on cost, I didn't want to go there, but it is another reason multi-cloud is a great advantage, because big organizations have a lot of negotiation leverage with each cloud service provider. And having the ability to not be locked into one gives you the best footing to negotiate your annual cloud contracts. So, but regardless, so when you start running in cloud, and most people know this, as soon as they start going into any of the providers and spin up some nodes, you can spend a lot of money very quickly. And I remember back when I started getting on the cloud, and I think I left like 100 instances running. And this is like my first job out of college, and I burned like 10 grand in like a weekend or something. And everybody was like really upset about that. And I was like, well, I'm sorry, I don't know. So that's not a unique occurrence.
Oh, no, it's not. It's not unique. Well, I think we've all done.
And I didn't get fired or anything, but everybody, was watching me much more closer after that. So anyways, cost control is a very important and difficult thing. And a lot of times what we see is these organizations want to put a budget to their cloud spend. And the way that, and each CSP has different ways of managing budget and enforcing limits, but they're all kind of different. And, what we wanted to do and started doing this years ago is make the cloud feel more like a conventional budgeting allocation system, where it's like, you as the organization manager of the spend of your computing cycles, you want to give this group $10,000 to spend on the cloud, and they cannot go over it. And that actually turns out to be a really difficult problem to enforce in the cloud. And the reason that is, and specifically in the type of workloads we would deal with, which is like HPC and ML, where they're big, lots of computers running for bursty amount of time, short amount of times. What ends up happening now, and I hope this changes at some point. I know some of the service providers have been working on this. You don't get the bills of what you spent for several hours, even up to 24 hours after you incurred the costs, right? So for us, where we have a customer that just spun up, 100 HPC nodes for 2 hours, and they just spent 10 grand, let's say, we won't actually know that for sometimes 4, 8, 12, 24 hours after the fact. So someone trying to enforce a budget of like $10,000 and they just spent that in an hour. And so this is what happened. Like when this was 5 years ago for us or something, when we had this problem happening where we have companies say, we can't go over $10,000. And suddenly at the end of a weekend, they're at $100,000 or something. And they just went over by $90,000 and everybody's freaking out. So what we had to do is create, and again, I hope the service providers roll this out themselves soon, so we don't need to make this, but right now we do. We created what we call a near real-time estimate. It's a 3-minute estimate of what your cloud spend is at any given point in time, generally in your own accounts, because we just orchestrate in your own cloud accounts. And then we have the option to enforce the budgets on that estimate. The estimates we found
you'll actually shut down jobs. You'll shut them down.
The administrators are able to set up rules, like when you get to a certain percent of your budget, shut down the resources because they're destructive actions. So there's a lot of checks. But we'll actually shut it down and stop the spend. If someone leaves on a huge cluster over, on a Friday night and then they go home, you won't go rack up a $200,000 bill. We'll shut it down kind of instantly.
Yeah. But so you guys are what you've done is you've made it easy now for anyone to upload their types of workloads into on-prem or in the cloud or even multi-cloud. So you've democratized HPC.
Yeah, and you make it sound magical, right? But really, what we're doing
is.
Yeah, but one layer down on what we're really doing, it's not. There's nothing really magic, right? We let our users, like the people that use our platform, create a solution of some kind. So a solution is usually consisting of like scripts. It may be like your Python code to do your, large language model training or something, right? It's some model or some bit of code. We let people load that into a place that packages it up with a little front end form. And, you can give instructions on how to run it. and we just become a job executor for the models that you create. And these things become like shareable entities, right? So they become, this is the democratization part. It's like I made a little, large language model, or even like a spatial or stable diffusion training workflow. And now I want to make that available to the rest of the people on my team.
Yeah.
Now we make that thing shareable. I can now take that little, it's almost like an iPhone app. And we used to call it that. It's an iPhone app for HPC and ML, right? It's like a little tiny thing that's all packaged up, and now I can share it with the rest of my team or the entire organization, and they can run it without having to like go into a terminal and install all my Python dependencies and everything. It's like a turnkey shareable entity. And we've done that with workloads and clusters and storage and a bunch of different things. Yeah.
Because you've made that easy, my brain went directly to AI, right? Because that's where all the money is being spent right now is AI.
It is.
Right.
Yeah.
And HPC clusters, they're great. They're great at running because they're massively parallel. They're great at training and doing all these AI ML workloads. You guys have come up with an easy way to define those workloads and make them shareable. You just opened Pandora's box.
Yeah. And well, it's interesting you put it that way because we've been very focused on HPC for our entire existence. And it's a niche world, as you've already kind of said. Right? Super niche world. But what started happening really over the last several years and we didn't really even think about it, right? It's just what people are using our platform for. They're using our platform to provision a bunch of nodes to do like ML training, or they'll run like our Jupyter lab or Jupyter notebook workloads and just put these on some big, instances in the cloud and do their model development there. It's almost like what Google Colab does. We can do it on more flexible sets of resources. And so we started finding that we're living in this world where people are using our platform for model development and then this process of scaling their training. I developed my model on a single node, single GPU. Maybe I did it on Amazon or an Azure GPU or whatever. Or some, let's say, Intel AMX accelerator.
That's what I like to hear right there.
Plug,
or some Gaudi 3
there you go.
Instances. Yeah.
And then this process of now moving it to a multi-node problem, multi-node training job, and then a multi-node, multi-GPU training job. It kind of cycles right back into the HPC realm. You need fast networking. You need fast file systems, and then it's really kind of the same thing, honestly. So
I think you hit it right on the nose. Anytime I'm going to run any work that spans multiple nodes, HPC, you guys have made HPC easier to use now, so it's an option for me now.
Yeah. The shape of those jobs kind of change though, like ML and the AI workloads, like, those are the actual like scheduling layer, I feel like is kind of evolving there, where it's moving a lot more to containerization and OpenShift or Kubernetes. But they are still, to start scaling the training jobs, they have the same requirements as a conventional HPC.
As a conventional HPC. Well, and HPC has been around a lot longer. I know. I worked in the workflow standards group, right?
There you go.
I was chair of that group for like 3 years.
Really?
Oh yeah. We learned there that setting up the job and actually running the job was easy. I have 10,000 jobs all doing the same thing. It's all the workflow and moving the data between all of that becomes the hard part.
It's the plumbing. It's the plumbing, which is kind of it's the boring pieces, right? But that's kind of what we do. We're like the plumbers of this infrastructure in a way, and just kind of tie it all together to make it easy.
Matthew, this has been very enlightening. I really see a great place for Parallel Works in the future, especially around AI ML. I think you guys are in a sweet spot right now. I think a lot of potential. Yeah, and thanks for coming on the show today. This has been very enlightening, and I learned a lot.
Yeah, great. Thanks, Darren. A lot of good questions. So anytime.
Well, hey, and now I'm thinking back to the good old days of the Global Grid Forum and Open Grid Forum, and projects I worked on. Oh man, I want to go work on them again. Thanks.
Good,
Thanks,
yeah, I
Matthew.
can have a beer, talk about those at some point. There you go.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.